Hello and welcome to this section of Calculus Extra Practice with Integration. In this section we're going to continue working with what we call the washer method of finding the volume of an object. And so we're just going to continue working some problems to build those skills. Now recall, the washer method is something you use when you have two functions. We call them f and g, two different functions, and they're both revolved around the x-axis like that. And because we have two functions, we're really interested in the volume of the shape carved out between those two functions. So you should have a hollow center. We've talked about that before. That's why we call it washer method. And what you're doing is you're going down and integrating along the length of this object, looking at the cross-sectional area, which all looks like, little washers. So far, all of the problems that we have done have had this sort of a curve up here and a curve here, and we're just kind of looking at in between A and B along to try to find the volume of the object. In this section, we're going to give you two functions. We're going to apply exactly the same methods that we've done before. There's nothing different. The only real difference in the problem type is that here, f and g, the two functions we're interested in, they're going to intersect. So they're going to crisscross, and so they're going to form an enclosed region. And we're going to revolve that enclosed region about the x-axis. And what we're trying to do is find the volume of that enclosed region. So a picture's worth 1,000 words. That's basically what we're doing. Let's go ahead and start the first problem, and you'll see very quickly what I'm talking about and why we need to go ahead and use the washer method to pull it off. So on a test or an exam or a quiz, what you might see is basically a problem that gives you two functions. So I'm going to call the first one y is equal to 1/2 x squared plus 3, or it could be labeled f of x. It doesn't really matter. And we'll give a second one, just like we've always been doing. In this case, it will be 12 minus 1/2 x squared. And on your problem, it might say, typically what we were doing before is we'd give two functions and we'd say, find the volume of the enclosed region between these two graphs, between A and B. That's what we've been doing before. In this section, I'm going to go ahead and let you know, and the problem will usually let you know, hey, these two graphs here, if you were to plot them, they actually cross. So they're not parallel. They actually cross at some point. So what we're trying to do is, whatever that enclosed region is, that between these two guys where they're enclosed, in that enclosed region, we want to revolve that entire enclosed region about the x-axis and find the volume of the resulting shape that pops up. So notice I didn't tell you that we're integrating between A and B. And that's because when you're trying to find the volume of an enclosed region like that, then you need to figure out where they cross. You need to figure out where these two graphs intersect, and those are the limits of the integration, because that's the boundaries and the limit of the enclosed region between these two guys. So it's much simpler if we just do it. Let's figure out, assuming that these two things cross, how do we figure out where they cross? What values they cross at? Well, if they truly do cross, then we must be able to set them equal to each other and figure out where they cross. So we'll set them equal to each other, and we'll say something like 1/2 x squared plus 3 must be equal to 12 minus 1/2 x squared. Basically what we're saying is the y values, if these things really do crisscross somewhere, the y values must be equal of these two graphs somewhere if they cross. So now that we've got this constraint going, let's go ahead and solve it. So we'll take this 1/2 x squared, and it's a negative, so we'll move it over here. That'll make it positive. So when we add these together, we'll have x squared on the left. And then we'll take this 3 and we'll move it to the right-hand side. So we'll subtract 3. 12 minus 3 is 9. All right? And so you can see that we just move the x squared over here, we move the 3 over here, and we get